Hello, hello.
Hello.
Hey, Vasilis, how are you?
Very well, thank you. I'll say hello to Ian. Hi, Ian.
Hi, how you doing? Long time no see.
Hey, Umesh.
Hi, I hope I'm audible.
You are
Yep.
audible.
Okay,
Cool. So I had I was thinking about how to present this topic, what's limiting IoT solution sales. And I thought a good way of doing it would be to present what are the ones that did really well, right? Like what are the ones that killed it and what are the rest of us doing wrong? So I'm interested to see what everybody's take is. Ming, how many IoT solutions have you built?
I wouldn't like to think several.
Yes.
But I can say it's the ones that go wrong that are more interesting.
Yep. Really? Oh, that's actually going to be some great perspective. Let me see if I can pull this bad boy up. So we'll get into it. Vasilis, you're new to the crew, so we'll get to introductions here in a second. I'm happy to have you here. So I'm sure you're welcome by more than just me, even though Ming can be very territorial at times. How do you guys know each other?
Projects a few years ago when I was at IBM.
Oh, okay. All right.
You were at Red Hat, weren't you, at the time? I think, Ian, I seem to recall.
I was back at, was it Dyadic or Morse?
Oh, maybe Morse. It could have been. Yeah, maybe Morse, actually. Probably Morse.
Morse, yeah.
All right. So here we go, ladies and gents. So welcome to Office Hours, DevHead's weekly office hours for September 20th, 2024. I'm Brandon Lewis. I'm going to be leading the discussion today, and we'll start off with some introductions. You already know my name. I've been a tech journalist for about 15 years, primarily in the embedded and IoT space, covering really everything from EDA to the cloud, but sweet spot right there in the embedded device space. And I'm really happy and feel fortunate to be a part of DevHeads, and then made a bunch of friends all over the world, which is awesome. Some people in some places I never thought I'd have friends. And so now I've got an excuse to go a bunch of different places. So looking forward to that. Ming, you want to go next?
So I'm Ming. I've been a Unix and Linux consultant for, it's well over 30 years now. And having started out my world in the IBM server world, come down, and about the past 15 years or so, I've been spending it in the embedded Linux type of things. And I'm now currently based over in France.
Very good. Vasilis, you're new, so who are you?
Yeah, I'll introduce myself. So I've got probably a fairly long background, originally in electronics. I was designing various military radios in the 1990s. And then I kind of got brought into IBM, having had a consultancy period with Detica, and spent about 10 years there doing supercomputers and, other things, absorbing data. And since then, I've really kind of gone down the data storage and analytics path. Well, I did have a little bit of time at Sanvanova, which is an AI chip startup, but we had some fun with the compilers there, to put it mildly.
That's great. That's great. Umesh, I think you'll love this topic today, since you've been making IoT products for quite some time and doing fairly well with them. But why don't you give everybody a little bit of background about yourself?
Hi, everyone. I'm Umesh from Pune, India, and I've been building embedded software and hardware for IoT solutions for more than 10 years now in India. Yeah.
In Pune, to be specific. Zach, you're up. And actually, before you go, or while you go, have you ever built an actual IoT thing, or has it been mostly like, smartphone consumer electronics that we wouldn't technically classify as IoT?
I do have one IoT thing. I don't know if it's an IoT thing. I just joined an ESP with a screen for a client. They needed a tablet for their HMI solution. I don't know if that counts as IoT.
It counts. We'll count it.
For sure. Hi everyone, I'm Zach, and I've been a software developer for close to 15 years now. I've spent most of my time focused on software and mostly web and systems development, but the last 5 years I've been spent learning embedded, and I'm happy to be here. Thank you so much.
Thanks a lot, Seth. Marvin, welcome.
Hi, I'm Marvin. I work in embedded Linux, mostly focusing on payments at the moment. So ask me anything about smart cards, stuff like that. Yeah.
Will do. Actually, I was thinking about you, and I wonder what the group has to say before we kick off. I was thinking, what classifies as an IoT solution? So when we started this whole IoT journey, and everybody else, if you're on camera or speaker, why don't you just say hi in the chat because I can't see you, but welcome everybody today. When we started this, when I started thinking about this discussion, I started going way back to the early 2010s when everybody was coming out with these huge predictions, like there are going to be 150 billion trillion, connected devices, and and I was an editor. Actually, I think I was doing a copy editor at that time, and literally every single article that I copy edited started that way. Like in the next 5 years, there are going to be however many, hundreds of millions or billions of things. But there was also this sort of counterculture that was like, oh, we've been doing IoT for a long time before that. And when I started thinking about how to present this topic today, I thought about Marvin because I thought about ATM machines. And I'm like, well, this is kind of like like an original sort of architecture like that, right? You've got an ATM, you've got like an edge device, and it's connected back to a database somewhere that's, monitoring how much money you got in your account. So it's definitely a continuum, and it's hard to say, Zach, whether or not, does it count as IoT or not, but we'll count it. But for today, because it's a little bit difficult and I wanted everybody to be able to talk about things with some commonality, what I did was I picked some consumer devices. So some really popular consumer devices that are definitely IoT devices. And I want to look at what made those successful and then see if we can figure out together what limits IoT solution sales on the whole, right? What do these things have? And I'm going to try and put the marketing stuff aside, right? But what do these things have that a lot of other devices don't have? And what do you need in order for end users in whatever the market is to see value and then make that purchase decision, right? And there's a lot we can do from the technical side to make that happen. Disregard the marketers. That's going to be the mantra today. Anyway, so starting off, most successful, some of them, IoT products of all time. So here's one of the early IoT products. So right around the 2011 timeframe, Nest came out with this thermostat, and it was all the rage. I don't know if you guys have a Nest thermostat. I have a Nest thermostat still. And, it was a touch screen. It connected to your phone. This was like a big deal back at the time. It's built on ARM Cortex processors. It actually has a surprisingly small amount of memory. It runs Linux, Wi-Fi, and 802.15.4. It's got a touchscreen display, and there have been tens of millions of them sold. The next one in the list here, Ring doorbell, ARM Cortex, and then it's got an Omnivision ASIC in there to handle a lot of the video processing to give you the HD video. Plenty of memory there for, to support the video. Also, Linux, you can connect these things up via cellular, Wi-Fi, 802.15.4, even sub-gigahertz in some cases, and also tens of millions of them sold. And then another huge one, number 3, the Echo, Amazon Echo. A lot of different people have supplied processors to the various variants of this. 256 meg RAM, 4 gigabyte storage, an Android-based operating system, Wi-Fi and 15.4. Automatic speech recognition was obviously the big thing here. Again, tens of millions of these have been sold, maybe more. And so then we look at the architecture, like the basic architecture of all these, and they're more or less the same, right? I mean, you've got You've got some device that can connect to nearby devices, maybe by something like some 15.4 type protocol. Then it has some backhaul out to the cloud where we do some storage or analytics, and that's pretty much it, right? I mean, there's nothing secret really happening behind the scenes there, with the exception of maybe what Amazon was doing with ASR. So I wonder, like, this is a pretty, it seems like a pretty nice formula, easy formula, right? Get one differentiating feature, right? Something that is, kick-ass or like totally new or whatever, and connect it and sell a bunch of them, right? So why are we so short, besides the fact that analysts like to use big numbers to sell research reports? Why are we so far short of our, however many hundreds of millions of billions of devices that are going to be deployed by like next year, right? I think next year is about the time that a lot of those projection periods are up. I want to start with you, Umesh. You've been building IoT devices and products for some time. Where have you failed? Where have you succeeded? And like, when you look around, what do you see as other people's where they're going wrong? What are some of the challenges?
So when I started in very early solutions, I thought maybe I would build some XYZ product which can solve some problem, and I was kind of confused in the convenience and solving a problem. In very early time, when I look back now, 5 years, 10 years back, many of this product that you have shown, they are very much is not a necessity right now. Like if I take my 10 years of experience, and now when I look at any solutions, if somebody wants to get it built from us right now, and if it's just a convenience, then I'm a little bit careful whether to invest my time or not. It's not because what's possible, what not, but because of the business proposition in it. And right now, because I'm dealing most of industrial IoT solutions, I feel strongly if I cannot show results to the companies, whatever the solution that is building, in just the span of 2 to 4 months, not more than that, then it would be very difficult to sell this product. So uh, it's very clear for me that I would not go just for convenience. Find if there is any pressing problem that I can solve, and then I can communicate and show them results. If they buy, that is fine. Otherwise, thank you very much. I take the same solution, go to other customer and say, okay, do you like this product that solve this particular problem? So this is how it works right now. I don't work with any consumer products anymore, just industrial IoT.
Yeah, and I specifically didn't pick industrial IoT because I didn't want to get us down into some niches and rabbit holes that other people had never heard of or don't understand. But it's funny that you did point out that like all of these things were things that nobody ever knew they needed, and then we figured out that we didn't actually need them anyway, right? But at the time we had to have them. It's interesting though that two observations here. In one case, we're talking about the introduction of something relatively new. Now, I know Ming will argue this, but the most of us had not seen speech recognition that accessible when Echo came out, right? The general population had not been exposed to something like that before. But in the other two cases, all we did was we just took something from over here and put it, connected it, right? Like we took video, right? And we connected it to a doorbell. And then in the case of the Nest, it's like, okay, we took your thermostat and we connected it to your phone, right? Like these were combinations of things that had already existed, and, that putting them together made them new. But in and of themselves, I don't know if I would say that there was massive innovation. So thoughts, Ming? You're
yeah, because I would say both for Nest and for Ring, we've got this product and we'll slap a Wi-Fi on it and shove it on your phone. That's not actually what made it successful. With Nest, what you're selling is the dynamic control. that you'll be able to change what your heating is depending on what's actually happening in real time, and therefore save you money. That was their big innovation. It wasn't slapping it on your phone. It was, we can adjust it dynamically depending on who's in the house. The Ring, it's not take a doorbell, slap it on your phone. It's the fact that you can then answer your doorbell from the other side of the world.
Mm-hmm.
That's the key thing. That was the differentiator. Because, I mean, I had a video camera set up on my door years back, but it was dumb. It was just here's a CCTV camera, and it would only work in the house. So being able to switch it to being able to answer your door and tell the Amazon delivery, can you leave it round the side, please, from wherever you are, that was their big selling point.
True. Okay. So let me specify. Yes, I understand that's the selling point. I also think partially a lot of that has to do with the marketing of it, right? Because like the components, what I've actually meant to say is the technology components separately existed, right? Like the internet existed, setting thresholds on anything, right, existed. Thermostats existed. All of these things existed. So the innovation comes in the combination of two existing things, right? Which is, there's nothing wrong with that, right? Not taking anything away from it. One of the things that I'm trying to get at here is where does the success or failure of an IoT product development lie on the technical side? Similarity here, all of them, with the exception of the ASIC that Ring was using because of for obvious reasons for video processing, all of them, everything is standardized except that thing, right? Like everything about it, like the connectivity is pretty standard, the processor is pretty standard, the operating system is pretty standard. Like they're all using some Android or Linux-based operating system. They're all using some ARM derivative there for the processor. They all have basic amounts of memory or whatever. So is the moral of the story here, gosh, you just got to come up with something super innovative and then you'll be successful and sell tons of millions of things? Or are there other ways that you should be innovating, in those fundamental infrastructure layers?
I think it's whether it solves a real problem that people actually have. I think that's the key thing. If it's a real problem that people find day to day and they can solve it, then they'll tell their friends, hey, this is actually really good. A silly example, but I've got a door sensor now installed at home very recently, just because my son, the first time ever, was letting himself out to school to get the school bus. And obviously, if I go out in the morning before him and my wife's gone out, then he's got to let himself out. And he was a bit incompetent with keys. But actually, just having that sensor tells me whether he's shut the door. If he hasn't, I'll get one of the neighbours to go and sort it out. But it's just, it's a silly little thing, very cheap solution, but it solves a problem.
So I think we can argue as to whether or not some of these things are actually problems. Like Amesh was saying, we have a lot of problems we didn't know that we had, right? But I want to ask you now, Ming. So in the places that things have failed, that you've seen failed,
yeah,
why did they fail? Like what were the reasons? And I don't mean they had a really bad product marketer, right? Like what did they do wrong?
Well, it'll be two things there. Firstly, there'll be the technical, what went wrong, and then there will be the delivery, what went wrong. Why didn't it take off? So, I mean, some of the technical things are the techies bit off more than they could chew in terms of, yeah, we can do this, no problem. And then you start getting into it and you go, okay, this is actually a little bit more complicated than I thought. And this, 3-week project has now turned into a 3-year project, and you still don't have a deliverable. But you've then got from the why doesn't something actually succeed and take off of, there have been various things that I've built, launched, and gone, excellent. And people have gone, yeah, and? It doesn't quite scratch the itch. It doesn't quite meet the need. Now, I don't know how much of that will come back to things like, you can't leave marketing out of it, because a lot of the marketing, when you're saying things like it has to solve a problem, even if you didn't know the problem existed, that's your marketing. It's the job of the marketing to tell you that you've got a problem, and by the way, this is what solves your problem.
You're welcome, guys. Yeah, and actually a big self-serving purpose for this session is that we're going to get into a series on IoT product lifecycle, right, and the various phases of it. And the first phase ends up being market research, right? What is the problem? Like Vasilis said, what is the problem that you're solving, and who are your competitors, and what are we actually doing here? To one of the things that Ming brought up, Amesh, technical challenges, biting off more than you can chew. One of the things that you see a lot, especially with like technologies like LoRa, right, is that in cases it looks like it might be a solution looking for a problem. Have you experienced that with some customers asking you like, hey, can we use this technology, or we want you to innovate and make something completely new? What's your experience on the technical side?
Yes, I often meet this kind of requirements where the or maybe the customer or client comes and say, okay, why not? We should use this. This sounds something new, crazy, promise something, which you can't just watch in some commercials or read in some marketing brochure or something. But then, I try to convince them on the expertise that we have. So if we have a good expertise on, let's say, a Zigbee stack or something, then I try to, convince them. It's not like we are so reluctant that we do not want to go for the LoRa path, but it has to be seen that whether it make a sense for us to invest a time in it. That's why I think it's very important to choose the niche and market and then stay into that lane when you build the solution. So 4 or 5 years back, when I used to take the project, I kind of opened for many variety of customers that I could probably see, okay, something can possibly experiment it, okay, and we'll figure out in the process. But I think as the time rolls on, right now I don't take this kind of things, but yeah, in house we keep building stacks. So for LoRa, we are keep innovating, building some small use cases in it, and see if that can serve the purpose for the client. If not, then we should be very careful. Otherwise, what Ming said is very true. I have experienced that. We think in the beginning that this project could be just for a couple of months, but then it's like years and year goes by and you don't have the result where the customer, because if your client doesn't go in volume production, you are stuck. The pricing is so complex in IoT. If he doesn't go, with him you basically share his failure.
Mm-hmm.
And I don't want to bear that anymore. If I'm getting older, I don't have a time for that. If you want to fail, go alone and fail there, right? If you do not reach to the volume production, thank you very much, go ahead, but leave me, right? So that's how I see right now.
Great. I also often wonder with IoT products from a technical standpoint, if the decision of choosing a processor and choosing a memory that is super efficient, right, for your, like an embedded developer would do, right? Like, let's code to a way that we can, have the smallest amount of memory possible, is counterintuitive in this use case, right? Because now if you can do firmware over the air updates, this device is dynamic. In theory, the device is dynamic, right? We can change its functionality. I don't know. How do you guys see device architectures today? Are you building systems that have more than they need so that they can become something else in the future, or are they still pretty embedded, or does it depend on what the client is? Vasilis, how about you? What are you working on these days?
So I get involved in a lot of AI projects, and I'm sort of seeing pushes to sort of doing edge AI. But I think actually when you come down to it, the sort of bandwidth and the power budgets, depending on the application, of course, and the location, are usually inadequate. There's lots of low power chips out there, but at the end of the day, if you're running some fairly intensive compute, you're not going to be able to do a true delivery, I don't think. So yeah, I think the definition of IoT and edge processing get a bit blurred sometimes. That's how I would state it.
Mm-hmm. So because of that, actually, the AI application is interesting because, again, just like an IoT device, right? The theory is you're going to keep updating this edge compute platform. In reality, what does that look like?
Well, I think some of the models, the models can be lighter, and there is some work going into lower precision processing, which actually does work. I was doing some work on that back at university back in the 90s, kind of 2-bit, well, technically 3 levels, but 2-bit computing for image processing. So you can do things, but I think there's always a bit of a mathematical risk around it, because some problems you can solve and some problems maybe don't yield to that. And then you're left with a higher power budget because you're having to do a sort of fuller compute stack. Does that make sense?
No, definitely. And I from a system architecture standpoint, when you come into that, and I'm not sure if you're how much of that's being dictated to you and how much you're dictating that on the architecture standpoint. What are some of the decisions that you're making there? Because there's a little bit of an unknown, right? I mean, in all of these cases, there's an unknown future potentially. How do you address it?
I think, well, that's the question. I think you've almost got to work out what you think the sort of power budget economics are before you start. Because if you have something that's too underpowered, you might not be able to solve the problem. If you have something that's too overpowered, you might be able to solve the problem, but then you might actually have difficulty deploying in practice because you just haven't got the budget available in terms of power, etc. So I think so you're almost forced to take a bit of a gamble and a bet. Actually, that's where the challenge is, I think. So there's different, you've got ARM, you've got Grok doing some interesting chips. They're all slightly different. But I think you need to get your calculations right up front, because the problem is you're committing to different architectures at that point. And if you get it wrong, it's a problem.
Yeah, for sure. Ming, is that where the marketing comes back in? How do you place those bets?
It definitely does, in terms of when you're looking at the volume of things that you're going to be shifting. That's going to have a huge impact on what kind of design. When you're doing your initial architecture, if you're going to be shifting a few hundred of these things, then you can be looking at, what is the rough price point. But I've had systems whereby I was teaching companies that were shifting millions of units. And by doing a little tweak to the architecture, we saved 5 cents per unit. Mm-hmm. And you're going, and this was a 3-month project. And you're going, well, 3 months to save 5 cents? Yeah, but we're now saving 5 cents times 2 million. We've now paid for the project to re-architect slightly to be more efficient, well over what that initial cost was. So to get that architecture right really depends on what you're going to be doing with it. What is its scale? What is its volume? What is its end use?
So I'd like to ask you what you define. How do you define an IoT system? Like, are you one of the people who's like, well, I mean, IoT's been happening for 50 years, or?
I would say I've been doing IoT for years, because the trouble with IoT, the definition of IoT is that's IoT. It's too fuzzy a concept.
Yeah. It used to just be data logging at the edge. Now it's actually processing at the edge.
Yeah.
In many cases.
So,
and it also used to be anything you want, take a piece of hardware, slap a Wi-Fi on it, it's now IoT. Right. That way we can get some good, startup funding of, the .com bubble, the AI bubble that's going to pop at some point, the IoT bubble. We'll slap IoT on it, and then we can go and get some more investment.
Right. So if you, in your, that example you were using, you ship 2 million units and you save 5 cents per unit, and you got $100,000 sitting right there, or whatever it is, right? Does that thinking, or should that thinking, still apply in a case like Bacillus was mentioning, where it's an unforeseen future, right? You are going to have to, I mean, with AI, we don't even know if the processors are the right ones to compute the, to compute the algorithms that are coming out. Should you leave the 5 cents? Like, save the 5 cents. You let the architecture keep it.
I'm going to bring this back to Yocto, don't you?
Yeah, that's right.
Because the whole thing here will be the beauty of a Yocto-based system. You can design on your low power, under-resourced potentially, but you're making your first guess. And then you start shifting units, and then you've got a bit more budget, and then you go, actually, right, we need some more power. So that's where I can make use of a Yocto-based architecture to go, okay, I've got all of my software and architecture working. I'm going to switch out my board, change my BSP, rebuild. I'm good to go. So by making use of a flexible framework, which Zach's going to tell me that Zeph is going to be wonderful as well, you don't need to worry too much about getting the details right the first time, because you've got that flexibility to change the horse as you're going on.
So how does this change, like, prototyping, right? Do you approach, or to all of you guys, and I want to pose this to the panel, is prototyping now sort of the continuous integration and delivery, like in actual product, not completely, but to some extent, where it's like, you know what, we're going to ship it, right? I mean, does this change things for you at least? We'll start with you, Ming.
Prototyping, yeah, the number of things you'll prototype, and you'll start out on your BeagleBone Black, and you go, right, I'm going to get a few things working here, and then you go, actually, that's good enough. It does the job. Mm-hmm. So I'm going to, solidify my design, and I'm going to ship with that to start with. I've actually shipped a system that, I was writing my prototype stuff in Python, and then you go, you know what? It works. It's good enough. Mm-hmm. I'm going to ship it as is.
How about you, Zach? What does ship ready look like to you today? And is it different from when you started?
I mean, it's getting more complete. I used to ship with wires exposed, and I'd have to be there for the thing. No, I've shipped an RFID timing system, and every time it was this, I had to be there, and I got paid for it. So I don't know if that's shipping, but it's getting better because now I have systems that are standing alone and they're being used without me being there. So the thing I'm wondering with the way Ming is explaining it is, it sounds like Ming prototypes up, like you go tiny and then larger if you need to. And then I'm more used to I start on the Pi and I want to aim to end on the PIC. So which one is it? Which do you start overpowered and then you kind of slim down, or do you go under budget and you go up? That's what I'm learning from this.
I definitely start underpowered, and then we'll work up, mainly because I will go, I'm Scottish, I don't like paying money, so I start cheap. And then only if the project then justifies spending the additional money will I add power, add cores, change the chip.
I wonder how that works today, because it may be because Ming is he's very experienced. So he's already experienced at this. And most people starting today will be starting at, when you start at the Pi, you start at a higher level, easier to develop on. And then you go slower. And the thing Ming is describing is do the hard work and then make it a little easier and then a little easier. So it's a tricky situation. Sorry.
Well, right. So this gets to design approach, right? Your design methodology, right? So, and this is Ming saw where I was trying to go with this, and he sort of built on this, which becomes, okay, well, now the way that you're building something needs to change, because what you need to do is you really need to modularize, what you're doing. That's what Ming's talking about with Yocto, right? And this is also probably part of the reason that Docker, et cetera, containerization has become so popular in this space. Now, it's a little bit harder because when you start getting Docker, container management systems and stuff involved, the embedded devices or traditional embedded devices don't have the resources to deal with that. But as Vasilis was saying, the definition of an embedded device is somewhat changing.
Balana?
Huh?
Balana?
Yep.
with Docker on IoT, whereby your entire image is actually a Docker image, and to upgrade your Balana hardware, you just roll out a new container.
Exactly. So if that's the case, then especially if you're developing code of any kind, right? Do you stop looking, and I'm going to ask you, Ming, and then we'll go around the horn. Do you stop looking things as, the inverse of synergy, like as the sum of its parts, not the whole, if that makes sense, right? Everything that you're doing is containerized. Everything is, so you break it down into, here's my package here. Here's my package here. And I've got to put, it's not saying I'm going to build a complete system, saying I'm going to build 50 packages, right? Is that an approach that you take?
It is very much the approach that I take, that each thing is, I'm going to use the word modular as opposed to containerized. So for the system I'm working on at the moment, where I've got a Bluetooth connectivity to my medical patch, and then I've got the cellular connectivity through to pass that data and all the things that are happening on the hub itself. Well, I can break that down into, so here is my Bluetooth to patch, and I can work on that in isolation. And then once I've got that data, I can then move to, how do I get the cell modem up and running? How do I now get the data over the cell modem working? And each individual section I can completely isolate, which makes the development of it easier. And then you can start right-sizing all the different components into the whole. Because once you've got the individual bits, you can then start bringing them together with a better idea of what you're going to need to make it all work.
When you're building a safety certified, you've been building medical systems recently. Does that approach simplify the like the certification? Because usually, like, basically, can the packages, can the modules be out of context, right? So they get reviewed out of context.
To an extent, yes, because things like, okay, we need Bluetooth certification. We need the FCC certification for our cell modem. We then need to have each of the individual components so that we've got all of the bill of materials of where each thing's happening, what it's doing, so that if you can break it down and have those modules, then it's easier to manage, easier to document, and easier to put through to the regulatory body to say, right, here are all the individual sections, and you can drill down as much as you need to for that regulation.
Awesome. So,
Brandon, I have a doubt here. The thing is, let's say if you modularize or containerize this particular development approach, let's say when we go for the certification with the regulatory body, whenever there is a change in design, there would be a bottleneck. We have to qualify different kind of certification requirements every time. So how we manage this continuous improvement or continuous development process and making a product when we are doing a containerized approach? Because whenever you change a module or a component in it, you have to go for recertification before you sell the product into the market. So how that's going to be a costly affair, because every product has to go a stringent testing cycle. So if you have to complete a CE certification for a medical device, you have to go through electrical safety. There is a specific standard 60601-1 and 1-2 that has several battery of tests to qualify to make through that particular standard. So when we change a small component in that particular product, it's gonna have that complete process maybe, because the thing is you will become back to square one again. So that's where the development cycle will go high. So we have to envisage a bigger picture, and we should be able to incorporate all the requirements of the standard from the day one to begin to build a medical device, I believe. Yeah. What do you say? What's your say on Jan?
Yeah, I think this is what Ming was saying. Sometimes, right?
But from a continuous integrate or continuous development and regulatory, don't mesh. because you can't have a continuous development cycle to then immediately start rolling out. You do your little bit of development, and then you wait 3 months as you go through the recertification.
So I think this is also part of the reason that Ming says it depends, right? Because there are different certifications, right? There are different types of compliance, right, that you have to go through, and in some cases, depending on how critical the system is, you're gonna, every time you make a change, the whole thing is gonna have to be recertified. Like if it's a life impacting device, right? Like you touch it, it's getting recertified. But there are opportunities because I mean there are a lot of standards and a lot of certifications out there, across industries. There are a lot of cases where you could probably recertify the container, right, or what you have in the container if everything else is already certed. So in that way, I mean this is a monumental cost, the certification in a lot of cases. And number two, it's also easier for you. Ming did a session a week or two ago now. It's all learned together on SBOMs, right? I mean, now think about yourself. You got a good SBOM going. You know where everything is, right? Even if you're doing continuous integration, this should be a pretty, at least internal operations wise, a much less painful task here if your design is built in this way, because you're pinpointing, where everything is, and then the traceability is pretty easy if you do have to go back to cert, right, to say, all right, this is where you made the change, here's how everything connects to each other, here's the package, you guys do what you do. Does that make sense, Syed?
Yeah, that makes sense because if we have that kind of provision, it would be great, because the thing is, otherwise doing the recertification completely again, it would be a cumbersome, costly affair, basically.
Yeah. And of course, sorry, go ahead, Mike.
Well, I was going to say, just from a certification perspective of when I was doing some work previous to the medical stuff, I was dealing with automotive. And for that, we had things like we had to do the FCC clearance.
Mm-hmm.
But when we were making changes to something that wasn't anything to do with the radio, we could actually skip the FCC recertification because nicely modularized, and therefore we only needed to recertify what had changed in terms of the entire product.
And that's like the infotainment system, which always blew my mind, right? The infotainment system in cars, I think you can get away with that, right? I think, yeah. So, in a lot of cars, the infotainment system today is becoming a major selling point. Friggin' 20-inch screens and stuff. So even though you may be operating in the context of something that could be safety critical, you might want to take a look at what the actual subsystem is that you're building and trying to certify, and see if there are opportunities there. Because this whole development methodology, if you're building an IoT product, you might have more than one swing, right? You might have a couple of different shots at hey, maybe we launched V1 and it was okay, but V4 is actually where we're gonna, Vasilis's models are gonna, knock them dead.
Yeah, well, the trouble with AI is anything that suggests you should retrain forces you to retrain, and then you're into deployments again. And actually, if you've got a regulatory process, that is quite difficult.
Yeah,
the frequency of updates is the data writes the code to a degree.
Mm-hmm. That's right. What kind of AI are you working with? Is it like pure like AI like unsupervised learning, or are you doing like neural networks? What are you doing?
Well, quite a lot of the time it is the sort of bigger neural network stuff. Sort of language models and sort of bespoke applications of those. But then there are some edge image processing requirements as well, which are kind of pretty common actually.
Yeah,
industrial inspection, those sorts of things.
Man, do you have? Well, I'll actually, I'll say this for offline because I have a question for you. I want somebody to tell me about non-vision and non-LLM based AI applications, because every time I talk to anybody, that's all they want to tell me about. But Umesh, for you, modular development, is that Is that an approach that you guys embrace? How do you go after building IoT products?
I completely agree this approach, whether it's a software. I want to add my part with adding the hardware integration. So I'm seeing more and more in industrial IoT space, more of the hardwares and sensors are coming up in a way that there's very little development you need. All what you do is you pick up the devices and you basically integrate and then you deploy into the factories. So that's where there are two things. One is the company who produces those hardware, they don't want to reveal the firmware because it's a part of the product architecture, right? So whether it's on the and then the software of these modules are written in a way that they can easily be integrated and can easily be talk and can be standalone like a Docker image or something. You can flash it, deploy it, and then use it. So I'm seeing more of the future is going to this direction, and maybe a couple of years from here we will discuss the difference between developer and integrator in some of the industries. That's where I see.
Kind of API calls kind of a thing we are going towards. Like they are just opening up an interface where just RS-232 or other thing, like just communication is happening in that particular platform, and you don't know how they're speaking and what they're speaking. Just the information
Yeah,
getting dumped into our systems.
yeah.
So that makes
Yeah.
a difference between a developer and system integrator there now.
If API is coming from Europe with the high documentation and you write just the function to get, call that API and then pull that data and integrate, then they are just the integrator, right? So yeah, and that's all even companies are interested these days to sell. So yeah, but that's the future. I mean, that's where we will go. I mean, 2-3 years down the line, every other product will be like that from bigger
So
companies.
yeah, it's like, and I want to ask Marvin something before, but I want to jump to Ming real quick. So Ming, memory is cheap, like comparatively, right? To what it used to be. So it's like, why do we even need Yocto? Like, why? Like, let's just make one standard Linux distro, right? And like, just not optimize at all. And then to Mesh's point, it's like everything's becoming plumbing. Like everything is becoming the water mains in your street, right? And then everybody just essentially ends up being an integrator, right? There's no OEMs of anything anymore. It's pretty much we have standard everything, and then you're just putting the different Legos together.
I'm not going to go for the one distribution to rule us all, because it depends actually on the reason I like to optimize. Because I'm going to optimize for my hardware. I don't want to have services hanging around that I don't actually use, because that's taking away, it's not even memory, it's taking away CPU usage. And therefore it's CPU cycles that aren't there for what actually I need to do, which is the thing that's going to earn us money. So I'm not going to want to have superfluous rubbish hanging around on my system.
There's another reason not to do that either. It's security, which is the big, another huge reason to do that. Marvin, I wanted to ask you. So, you're working in a very specific space right now. With the payment systems and such. What's the development methodology? What's the approach there? How are you looking at the architecture of the systems, and then are you developing everything holistically, or are you modularizing it? How do you approach it?
Our approach is basically mostly modularized. So, for example, we in East Africa, mobile money payments are a big thing. So, as a payment company, a lot of people don't use, like a person would go a whole year without using their card, but they do have a bank account, yes. But mostly the main purpose of their bank account is connecting to their mobile money platform. So most people in Kenya do payments with their mobile money. The money will be pulled from the bank account, put on their mobile money, and they'll do that. but now you're selling a product that is card payments. So we had to now go back and redesign the whole product to encompass all kinds of payments. So majorly, I'd say the company makes more money on mobile payments than that. So we had to go for, the design was really modularized in a way that we could, like right now, the company is moving to the south of Africa. And the mobile money is also going there. So we built it. It's I'm still for modularization. So we built it in a manner that any other form of mobile money payment can just fall into our design with less than a day of coding. Yeah.
This is actually a really good point. I'm glad I asked you, because that is another huge advantage of this modular approach to development. Because, right, like it's like not only can you potentially reuse things in other places, but what Marvin was just describing is that there's now I mean, for a lot of us, a reverse use case, but another use case that's part of the same system, right? So it makes it a lot easier for your system to scale. So I think that's a really interesting observation, and thanks for sharing that. All right. Anybody have any other things to add about what they think is a contributor or a limiting factor in IoT solution sales from a technical perspective?
I could pick on the UK's mobile network and actually say it's quite poor and inconsistent in terms of coverage, because actually that can be very frustrating for users, is how I'd put it.
Yeah, I mean, I think that's also when I looked at these really successful ones, something I touched on very briefly earlier was everybody picked stuff that was kind of baked, right? Like, okay, it's Wi-Fi, it's 15.4, right? And the reason for doing that is, yeah, I mean, if you end up with a crappy cellular network or whatever, right? Then things start getting outside of your control. So limit those external factors.
Yeah, I think 5G's got a lot to answer for, actually.
Honestly, I've been thinking that for years. It's like when is this massive improvement in bandwidth and performance going to hit my phone? Because I haven't seen it yet. Anyway.
Well, too many cells covering too small an area is actually much easier with 2G edge type stuff, which you can still use. But actually, 3G was probably better than 4G and 5G in many ways for range. So,
did the 2G? Did they sunset any? I thought they sunsetted all the 2G.
Not sunset yet. No, it's still around, but I think it will get sunset. But yeah, we pushed up the stack at some point, and it could be painful actually, because you're suddenly into very small cellular coverage areas, because obviously the higher the frequency, the less the range.
Right, that's right. It's like all of a sudden Deutsche Telekom and Verizon are like, wow, we got to build a whole lot more towers.
Yeah.
But eminent domain, make sure you guys guard your properties.
No one ever got meshing working properly, because I think 5G is supposed to be able to mesh between devices, but it doesn't really do that.
Yeah. There was we got promised a whole lot of stuff. It'll all be in 6G. So don't worry about it. Okay. Anybody have anything else they want to add? I appreciate the feedback so far. Zach?
Somebody has asked a question in the chat. Sorry.
Oh, thanks for pointing that out. IoT doubt. Nowadays, predictive maintenance is being included inside machine manufacturing itself. This is narrowing down startup ideas and could make to make predictive maintenance sensors. Can we discuss the trend of predictive maintenance sensors for a minute, please? Oh man, predictive maintenance is not new, and I think one of the gifts and curses of the industrial IoT sector is that the life cycles are much longer. So a lot of the concepts that have been happening out in the consumer IoT or the rest of the IoT the industrial IoT has had a lot of time to vet them and put them through their paces. I don't know who amongst us, I think Umesh probably does, has experience with predictive maintenance, industrial analytics. I would be shocked if Ming didn't. But what do you have anything to add there, or anything you can comment, Umesh, on?
I just dropped a link into the chat, and it's a wonderful company. I guess it's from US. They have a platform that says machine metrics. So they basically, like in Google Analytics, you take all the web and then all this data and you do analytics, right? So this company is making fantastic product where you can literally monitor the machine health, machine parameters, and everything. So if you just study about their platforms and learn about some use cases, you will get a great reference to get what's happening in the predictive maintenance. By the way, this is the best. I mean, I love the business model they have, the product and services they have, right? So, and for India, I think if somebody potentially wants to do it, I would say this is the right things to explore. Yeah.
So what's the business model here? I mean, is it more data? Is it data driven? I mean, is that what it is?
Yeah, they are basically like they have the hardware as well, real physical hardware as a gateways. But I think the main product that they are selling is basically a SaaS kind of platform where they have the analytics, and that's what the companies are interested in. Uh, I mean, if you have a data 2 months, show them the value in companies, right? Here is the dollar. That's what I was talking in the beginning. So
I don't know. Maybe I'm jaded, but do you guys remember when IoT came out? The first wave of of companies were all IoT cloud platform companies, which a lot of them actually ended up being data visualization companies who like pretty much like took data off of some sensor, put it on some pretty dashboard, and that was kind of it. And they got billions of dollars thrown at them. There were so many of them. And I think it kind of turned a lot of people off, because at the end of the day, people started going, okay, so this is just my sensor data in a cloud-based chart, and what else, right? So I think one of the things here, Puneeth, is if you're going to do, I'm assuming when you say predictive maintenance sensors, you're not talking about actually creating sensors, because if you're talking about actually creating sensors, then you're talking about, you're going to need a lot of money. But if you're talking about the application of data, right, you need to have a lot of domain knowledge in whatever the specific thing is that data that you're trying to analyze. Like here, it makes me, I'm sure that these guys, one thing that I'm curious about with what Umesh is saying is like here, condition monitoring, production monitoring, predictive maintenance monitoring. These things are great. If this is an enabling company and they can pair it with somebody, internal or external, who knows everything there is to know about that customer's use case, the value is going to be there for you, Puneeth. You gotta know a use case forward and backward, and then you can use these types of solutions as enablers, because otherwise, deriving value is going to be left to the end user, and then what are you there for? So
I think if the company could able to bring the actual physical hardware as a product and then the platform, then only I think you can add the value. What happened in 2017 and 2016 when all this platform came in, like more than 25 plus companies, all this big companies, either they have a product as a cloud service, or some other group of a company has the hardware but no cloud. Then what about the integration? We're gonna do this hard part. And no, I think the reason why people buy some of the solution that they buy from us at this moment is because they are really concerned that what if the companies, the hardware that they buy from a companies outside of India, then they say, okay, we will write you some emails as a support, and then email doesn't. solve any problem in a plant, and now there are the losses that the company is making. So they think if we have somebody who can give a better support and service, and when you have the hardware, if you have a control on the hardware, then it's more possible. So if you just build a platform, then it's very difficult. I don't know how, because I spent 5 years to find money in there. There's no money.
That is actually a huge thing. It's been around for a while. Again, it's like everything old is new again kind of thing. But managed services, right? Like, so these companies are now, like hardware as a service, sensor as a service, right? And then you deploy your hardware. You're able to, what Umesh is saying, you're able to control the infrastructure around it. You can get the data, and then, you can provide the data out in various ways where maybe, you're taking some of the AI algorithms that Facilis is working on, you're applying that to that data there. Then you're controlling these data visualization dashboards and giving them unique, bespoke insights based on what their application is. And the great thing is then you get to have recurring revenue, right? Not only on the SaaS, but you can also get recurring revenue on the endpoints, on the hardware endpoints. And so that's something that's sort of coming into vogue right now, or in the last couple of years.
Yeah, if there is no real physical product that you can deploy, then I'm a little bit scared and careful.
For sure. Ming, you have anything to add? How many factories have you built?
I haven't actually built any factories. The only predictive stuff that we're doing is always looking at when you've been developing a solution and it's been out there in the field for enough time, and you're doing your fault analysis, because things always go wrong. And that's when you can start building up your predictive model on, oh yeah, I've seen this sort of thing happening. It's about to die, or all the other ones that show this particular type of behavior, it's about to die. Mm-hmm. So, start looking at, do we need to ship out a replacement? Do we need to, whatever we do?
Mm-hmm. For sure. Thanks for the question. Really appreciate it. Anything else? Please throw it in the chat. One reminder for everybody is there is an AMA coming up on Yocto. So if you're working with Yocto, Ming will be answering some questions. We'd love to field your Yocto, more specific Yocto questions than we would typically get in like a webinar Q&A. Throw them into the community and we will field them live.
On that, I've actually created a little post on the middleware and OS as a point that if people have got questions, if they want to be able to respond to that post, I've seeded it with a few of the questions that I've been asked offline, so that it gives you a hint about some of the things that we're going to be talking about. But add in more questions and see how it goes.
Cool. Awesome. All right. Well, we went over time. Sorry, guys. It's my job is to keep us on track. So I failed in my job today, but good discussion. I'm really looking forward to marching us into sort of an IoT product development lifecycle series where we can take a look at, hey, look, these are the various phases of IoT development that you need to go through, and the best ways of tackling those. So I'm going to skip right ahead in our PowerPoint. Can we do anything to get better by next week? We'll get to that next week. But thanks for bringing your grain of sand to the community for the week of September 20th and the preceding 4 days and the next couple. We'll be having an engineering hour coming up on Sunday at 1500, which is the same time that this starts. It's going to be with Edison and Njiri, and we're going to go further into CMSIS, RTOS API, and how you can leverage it with mutexes and semaphores. So if you're into embedded software space, you definitely want to check that out. Find the link in the server. And that's it for today. We'll see you next time, guys.
Cheers, everyone.
See ya.
Bye.
Bye-bye.
Bye. Bye.
Bye.